A robotic camera is moving through a narrow tunnel, 480 feet above the ground, inside a structure that has stood for 4,500 years, and then it stops. There is a stone slab blocking the way, sealed shut, untouched. The researchers staring at the monitor don't say a word, because they know, whatever is behind that stone, no human being has seen it in over 4 millennia. We are in Egypt, the Giza Plateau, home to 138 pyramids, ancient structures that have survived dozens of earthquakes, violent desert storms, and centuries of time. And yet, not one has collapsed. Not one has shifted, not even an inch. The tallest of them, the Great Pyramid of Giza, rises 480 feet into the sky. Its base covers so much ground that 9 football fields could fit inside it, side by side. It contains 2.3 million stones. Some of them weigh 50 tons each. 50 tons. That is the weight of 3 full passenger buses stacked on top of each other. And the total weight of this pyramid? 6 million tons. That is 12 Burj Khalifas. The question that has haunted researchers for centuries is simple: how? Before a single stone was placed, the architects had to solve something that still baffles engineers today. They had to align every side of this pyramid perfectly to the 4 compass directions: north, south, east, west. And they did it without a compass, without optical tools, without GPS, without anything we would recognize as a measuring device. So how? Experts believe they used something far older than any tool: the stars. Specifically, a pair of circumpolar stars, stars that rotate around the Earth's North Pole. By tracking the exact midpoint of their arc across the night sky, the architects could find true north with remarkable precision, and that's what they did. No instruments, just darkness, patience, and a sky full of stars. The result? Every side of the Great Pyramid is aligned to within a fraction of a single degree. Think about that for a moment. Once they knew which direction to build, they faced the next problem. The ground wasn't flat. And if the foundation of a structure this heavy was even slightly uneven, even by a few inches, the entire pyramid would eventually shift, crack, collapse. They had no laser levels, no surveying equipment. What they had was water. Experts believe they dug channels around the entire 13-acre construction site, filled them with water, and used the natural level of the water's surface to mark a perfectly flat baseline. Any rock that sat above the waterline was chiseled down. Any depression was filled. Simple, genius. And it worked to within 2.1 centimeters across the entire base, a base the size of 6 city blocks. Now the direction was set. The ground was level. But the stones still had to be cut, and these weren't ordinary stones. We're talking about limestone blocks, some weighing as much as 50 tons, that needed to be cut into near-perfect rectangular shapes. No power tools, no grinders, no steel saw blades. What they had were copper chisels. But here's the thing: copper is soft. You can't cut granite with copper alone. So the ancient engineers added something to it. They combined copper with tin to create a harder alloy, what we now call bronze. And using wooden mallets to drive these chisels, teams of workers would chip away at massive limestone blocks hour after hour, day after day. It was slow, brutal, back-breaking work. But they were patient in a way we can barely imagine today. The limestone came from quarries in a city called Tura, 250 kilometers away from Giza. 250 kilometers, and these blocks weighed 50 tons each. You couldn't use animals. No animal could pull that kind of weight over that kind of distance, and there were no trucks, no cranes, no wheels large enough to handle the load. So, what did they use? The Nile, a river that ran between the quarry and the construction site, became the world's first heavy-haul transportation system. Workers loaded the massive stones onto wooden barges and floated them down the Nile toward Giza. But loading and unloading a 50-ton block onto a boat? Experts estimate it required at least 500 workers, working simultaneously just to move a single stone. And there were 2.3 million of them. Here is where the story gets truly impossible. The limestone blocks were cut. They were transported. They were stacked, one on top of another, rising higher and higher into the sky. But how do you lift a 50-ton block to a height of 480 feet? No cranes, no pulleys, no engines. The leading theory among experts is ramps, massive earthen ramps that spiraled around the outside of the pyramid as it rose higher. Teams of workers, using ropes and sleds, would drag each block up the ramp to its designated position. Can you picture it? Thousands of men, pulling, sweating, in the heat of the Egyptian desert. One stone at a time, over 20 years. That is what it took. Now here is the part that no one could explain for a very long time. The outer casing of the pyramid was limestone. We knew that. But the inner chambers, the rooms deep inside the pyramid, were lined with something else entirely. Granite. And granite is not limestone. Granite is the second hardest natural material on Earth, after diamond. Even today, cutting granite requires industrial diamond-tipped grinders running at thousands of RPM. So how did ancient Egyptians, with no power tools, cut granite so cleanly that the seams between blocks are almost invisible? For years, no one had an answer. Then, after decades of study, experts finally cracked it. They used a blade with no teeth, a completely smooth copper saw weighted on both ends. Workers would pull it back and forth across the surface of the granite, and in the gap between the blade and the stone, they poured fine sand. The sand acted as an abrasive. It ground through the granite slowly, grain by grain. How long did it take to cut a single granite block this way? 4 months. But even with all of these answers, something didn't sit right with the researchers, because none of this explains one thing: the precision. The sides of the Great Pyramid are set at exactly 51.5 degrees, not approximately, exactly. Each face is aligned to within 0.05 degrees of true north. The base is level to within 2.1 centimeters across 230 meters. These are tolerances that modern engineers struggle to achieve with laser-guided machinery. And 4,500 years ago, none of that existed, which brings us back to that robotic camera. Inside the pyramid, blocked by a stone slab, the researchers decided they had to see what was on the other side. They attached a small drill to the front of the robot. The drill bit through the ancient stone. A camera, no bigger than a finger, was pushed through the hole. And on the other side, for the first time in 4,500 years, something came into view. What they saw in that chamber, sealed away from the entire world for 45 centuries, raised more questions than it answered, because it didn't look like what they expected. It looked like something had been left there deliberately, something that was never meant to be found. We have answered some of the questions. We know roughly how the stones were cut, how they were moved, how the ground was leveled, how the directions were set. But the deeper question, the one that keeps experts awake at night, remains open. Why did they build this? What drove a civilization 4,500 years ago to dedicate 20 years and 100,000 lives to stacking rocks into the sky with an accuracy that still defies modern explanation? And what is inside that sealed chamber that no one was supposed to see? Some things were not built to be understood. They were built to outlast us. And so far, they have.